Well, hello everybody. And I am here at school getting ready to do lesson 8-2. Hopefully you are primed and ready to go and you have your lovely calculator. Hopefully you have picked up yours. It won't be yellow, it should be blue. But hopefully you've picked up your calculator by now. Okay, this is the calculator that is needed so that you can manipulate the problems and get the right answers without having to do too much trouble, and be able to use it on the EOC without having to learn how to use different calculators. All right, here we go. 8-2. 8-2 deals with special right triangles. Now, hopefully you understand they're called special right triangles not because they're special, okay? They're called special right triangles because they happen to fall into one of two categories, okay? So meaning there are two different categories of special right triangles, and they're dealt with their angle measurements. Okay? And these are shortcuts. All right? These are shortcuts on how to find the sides of a triangle when you only have one side. Now, we used the Pythagorean theorem when we had two of the three sides, correct? And finding one missing side was easy. It was simple algebra. A squared plus b squared equals c squared. And we could solve for the a, or solve for the b, or solve for the c. That's the easy one. Special right triangles is a shortcut way on how to find the third side when we only have one. All right? Now there's two frames of thought, two ways of thinking. You can memorize the rules or you can memorize the picture. Okay? So I'm going to go through the memorizing of the rules first, and then I'm going to do what I think is the easier of the two and memorize the picture. All right, so the first type of special right triangle is called a 45, 45, 90 degree triangle. Now the reason it's called a 45, 45, 90 is because two of the angles are equal. All right, so let's look at a 45, 45, 90 degree triangle. And what are some of the things that you know that can happen when two of the angles are congruent? Well, they can show you with congruency marks, okay? They can show you two of those angles were congruent with congruency marks, and that's your visual representation of what a 45, 45, 90 is, okay? So you could also look for the angle measurements. So they might do it like this and put a 45 in here, okay? That would be a 45, 45, 90. Now remember, these are all visual representations of what a 45, 45, 90 is. They don't always tell you this is a 45, 45, 90. You must be able to see it. Okay? Here's another way of knowing that it's a 45, 45, 90. They could do this. Because if the angles are congruent, then the sides across from the angles are congruent. Correct. So this is another way of showing a 45, 45, 90. They could also use the word square. Because when you look at a square, two of the sides would be 45, two of the sides would be congruent, and the other two would be. And when you draw a diagonal, it makes two 45, 45, 90 degree triangles. So there are different ways of them telling you it's a 45, 45, 90 without them telling you it's a 45, 45, 90. So you got to want to memorize these pictures and understand that, hey, in this type of triangle, I'm going to remember these two rules, okay? So hopefully you know there is one side of a right triangle that always has the same name. What side is that? You are correct. It is the hypotenuse. This side is always the hypotenuse. It will never have another name other than the hypotenuse. It's always called the hypotenuse. It will not change. In any shape that you have a right triangle, the right angle always points to the hypotenuse. That is the hypotenuse. Now, The other two are called legs. And in a 45, 45, 90, the legs are the same, right? So the measurement that's here is the same as the one here. All right, here are the two simple rules. To find a leg, always do the hypotenuse divided by the square root of 2. Okay, and in a 45, 45, 90, to find a hypotenuse, always do the leg times the square root of 2. Okay. So if you need the leg, always multiply by the square root of 2. And if you need the hypotenuse, you always divide by the square root of 2. Okay. So you can remember that. Now I'm going to show you the picture version, which I think is by far easier. Okay, and it requires some common sense thinking. Okay. All right. Then the second type of triangle, the special triangle, is a 30, 60, 90 degree triangle. Now hopefully you see one angle is smaller than the other. Notice 30, 60, 90. Goes pretty much in a pattern. Okay, from 30, double that, to 60, to 90. All right. Now, 30, 60, 90 degree triangle also has a hypotenuse. And this side will always be called the hypotenuse. Now, I'm making a big deal of it now because later in 8.3, the other two sides have different names that change. But for right now, we just need to know, can I find the hypotenuse? Oh, where did my hypotenuse go? Okay, giggle, giggle. All right, so this side is called the hypotenuse. This angle measurement is the 30, and this one is the 60. Can anybody tell me why I know that top one is the 30? All right, in review, you probably are correct that the smaller angle is always across from the smaller side. And the larger angle is always across from the larger side. Thus, the biggest angle is across from the biggest side. And that's why we always say the hypotenuse has to be the largest number. Okay? It has to be the largest number because it's always across from the largest angle. You can't have an angle in a triangle larger than the 90-degree right angle because that would not add up to 180 degrees, right? All right, good. So, what do they do with these pictures? I can tell you that the pictures just change orientation. They spin them, they flip them, they put two different ones together. They do a lot of different things, but these still revolve around the fact that there are two special triangles. All right? Now, the rules for this are a little bit more complex. Okay? So, to find the short leg, now how do I know it's the short leg? Well, it's always across from the 30. So you have to know where the 30 and the 60 are. And they have to give you those. Okay? Or they'll give you hints that they're 30 and 60. And I usually just redraw the picture so that it always goes in the same direction. Okay? Or you can spin the book and then draw the picture. To find the short leg, you will either divide. Okay, so you're going to divide either way. You'll either divide the hypotenuse by 2 or the long leg divided by the square root of 3. Okay. So to find the short leg, you're either going to take the hypotenuse and divide by 2, or the long leg and divide by the square root of 3. Well, Mr. Frazier, how do I know which one I'm doing? They're going to give you one of the two. They're either going to give you the hypotenuse or they give you the long leg. And then you find the short leg. All right? The next rule is to find the hypotenuse, you must multiply, okay, and it's going to be the short leg times 2. Okay. To find the long leg, you must multiply short leg by the square root of 3. So this is your choice. You can memorize all those rules. That's fine. It's not a problem. Okay. You get one measurement and you read the rules and find the other ones. Now, I'm going to tell you my shortcut, my cheat. My cheat of the cheat. Okay, what do? Well, I make it very simple. I know I'm going to have 2 pictures. And on your reference sheet, you're also given these 2 pictures. And I always redraw my pictures to look the same way. Now the 45, 45, 90 is easy. All right. The tricky one is the 30, 60, 90. I've got to try and turn it so that I always have the short leg on the bottom. Okay? So that means my 30 is always up here. Which means I've got to rotate things a little bit from the original picture, but I always draw my same picture. And then I always do this. Oops, I made a mistake. You've seen it first here. Mr. Frazier has made a mistake. I'm going to cover it up, though, with some lovely whiteout. Look at that. Mr. Frazier has no longer made a mistake. All right, so I put the number 2 on the hypotenuse and the number square root of 3 on the longer leg. All right, now, your reference sheet has these pictures. Your reference sheet will not have these words. Your reference sheet has these pictures. Your reference sheet does not have these words. So you can memorize these words, or you can memorize the nice little short thing I teach you about this. All right. If I redraw this, hopefully everybody understands. If your hypotenuse, well, let me explain to you this way. How can you make numbers bigger? Hopefully you said multiply. How can you make numbers smaller? Hopefully you said divide. Now let's look at the picture. We know the hypotenuse is always the smallest. Not. What is the hypotenuse? It's always the biggest, which means everything else must be smaller. So that means if I'm given the hypotenuse, to find any of the other sides, I've got to divide. All right? Now, I teach this little ditty. If you can draw that picture correctly, every time you go down, you divide. Up, you multiply. Just like the numbers do. Down, divide, up, multiply. And the numbers you're going to divide or multiply by are already on the picture. So let's say the hypotenuse was 8. I want the leg, I'm going to go down, and it's going to be 8 divided by the square root of 2. And I use my handy-dandy calculator. 8 divided by the square root of 2. And the answer is 4 square root of 2. Now, do I need to find the other side? And I'm hoping you go, well, no, Mr. Frazier, because both of the sides are the same. Correct. This is an isosceles right triangle like we know up here. And we know that they can give it to us in different ways. But once we know the angles are congruent, we know the sides across from them. So whatever this measurement is, this one will always be the same. Correct. So the only thing I'm ever going to do is either go down and divide, or I'll go up and multiply. If I go up and multiply, well, Mr. Frazier, what am I going to multiply by? That same number, the square root of 2. Now, why does this become difficult at times? Because people mess these numbers up. Notice this one's the square root of 2 and this one's 2. They'll flip them. This is the square root of 3. This is the square root of 2. They'll flip them. All right? But that's why you have a reference sheet. Use it. Draw the same triangle. Put the measurements in the same order and you won't have a problem. Down, divide, up, multiply. Down, divide, up, multiply. Down, divide, up, multiply. Okay? Those are the only two directions you can go, is down and up. Down and up. Okay, but Mr. Frazier, this one looks a lot more complicated. No. Let's just make a number. 3 square root of 2. Okay. Well, Mr. Frazier says if I go down, I divide, and I go up, I multiply. Well, let's say they want this side over here. Well, some of you would go, well, he didn't say anything about going sideways. And that's correct, because you can't go sideways. You'd have to go down first, then up. Like a ball. It has to go down, then it bounces back up. So in other words, I'd have to find the short side. The only time I don't need to find the short side is if they give me the short side. But inevitably, if I need to find any other side of that right triangle, I'm going to have to divide first, then go up. Okay? So I would divide first. This would be 3 square root of 2 divided by 2. Yay! Pretty easy. I went down, I divided. 3 square root of 2, and I went down, I divided. What number do I divide by? The number that's already there, 2. These are my magic numbers, my special numbers. So when I go down from the hypotenuse, I will divide by 2. If I started here and went up, I would multiply by 2. And notice, if I multiplied by 2, I'd get this answer. All right. But we were looking over here. Well, I went down first. Now I'm going to go what direction? So when I go up, I multiply. And it would be 3 square root of 2 over 2 times the square root of 3. Now, do you have to have a heart attack and go, oh my God, that looks so hard? No. Here's magic calculator. And we type in exactly what we see. Exactly what we see. 3 square root of 2. Over 2. And the answer is 3 square root of 2 over 2. Now we multiply that times the square root of 3. And we get 3 square root of 6 over 2. Now, could you put that all in the beginning? Yes. 3 square root of 2 over 2 times, notice I just put the parentheses, square root of 3. Notice what I wrote on my paper looks exactly how I wrote it on the calculator. I hit equal, ta-da. And then if I needed the decimal answer, well, how do you know if you need a decimal answer? They'll say round. Round your answer to the nearest tenth. I hit the arrow keys, ta-da, 3.67. All right, so down we divide, up we multiply. Down we divide, and the numbers are the same because the two sides are equal. And that is special right triangles. Now you're going to practice some problems. Remember, drawing these out and following the math should be relatively easy. All right? Do the guided practice or the beginning practice problems so that you can check them when you come to class. And then you can continue on the homework once you get here. Work well.